Okay, discrete or continuous variables. In short, discrete variables have to exist as whole numbers. There's nothing in between them. On a graph, you'll see them as discrete dots. 1, 2, 3, 4, 5. Continuous variables do not have to be whole numbers. They can be any real number. So you'll see those as a line. You're allowed to have decimals or fractions involved. You can have values in between 1 or 2 or 3 or 4 or 5. I think of this in an example of, let's think of this as like the percent capacity of an elevator. A discrete variable would be the number of people in that elevator. You cannot have a fraction of a person unless you're in some sort of awful horror movie. Whereas a continuous variable might be the amount of mass in an elevator. You can have 118.73 kilograms. That makes perfect sense, but you need to have 3 people or 4 people. You can't have anything in between. So that's the difference between discrete and continuous variables. Makes it a little easier then to think of which variable is which when you're looking at, or what type of variable you're dealing with when we're looking at these examples. 100-meter sprint, we can definitely have variables. Really the only limitation is how accurate our stopwatch is. Continuous. We're not stuck on whole unit seconds or milliseconds even. Number of students who pass Math 10. You can't half pass, you either pass or do not. So that is a discrete variable. Height of students. If we want to get accurate enough, we could measure down to the micrometer, definitely have more and more decimal places on that particular variable. It is continuous. Shoe size is interesting. We can go down to half shoe sizes, but that would still be something where you can't have something in between. We could have 4.5 as a shoe size, but we can't have 4.10 or pi as a shoe size. It is still discrete. There are bumps. We go from here straight to here. We go from size 4 to size 4.5. There's nothing in between there. All right.